Okay, hello everyone. So we are doing this data structures, and today we will discuss about stacks and queues. So again, these were the lessons that I gave in 2022, and I'm just now uploading all of them one by one on YouTube in case they will be helpful for someone. So let's go. We know what a data structure is, right? Data structure is basically the organization of the data into a structure. So basically you organize the data in different ways, and that is known as a data structure. There are different ways of organizing data in the system, in the computer, and then that is known as data structure. For example, arrays, linked list, stacks, and queues, etc. So all this is a bit of a theory, so we'll just go very quickly onto this. There are different kinds of structures, right? When you are storing data into the memory of a computer, it is known as a storage structure. And whereas uh, when the storage structure is of a file, then it is known as a file structure. Okay, and this is basically used for manipulating the data. So for example, data in an Excel sheet is a file structure, or data in some kind of a document is a file structure. Then there are four basically things that data structure specifies, and that is the organization of data, accessing method, degree of associativity, processing, alternative for information. So we'll discuss what these points mean. So basically, how the data is organized. Is the data into a tabular format, or the data is in the bullet format? The data is in a data is a pictorial format. Data is is it a image, is it a sound? Data is of the sound type. So how, what is the type of the data, right? Then accessing method, how would you retrieve that data? Okay, then how the data is related to each other. So the data, for example, let's say an information about car. So a car will have a car name, car will have a car price, car will also have the year of production. So how it is associated to different columns of the data, the how they are associated to each other. Then there is processing, alternative for information, right? Meaning, what is the alternate text for this particular data. So algorithm plus a data structure is known as the program. What data structure covers basically, कितना स्टोरेज लेगा, कितना मेमोरी लेगा, कितना टाइम लेगा टू एक्सेस दिस पर्टिकुलर डेटा. डेटा मेमोरी में कैसे स्टोर्ड है, मीनिंग डेटा कहाँ स्टोर्ड है, बेसिकली स्टैक में स्टोर्ड है कि हीप में स्टोर्ड है, रन टाइम एक्सिक्यूशन में स्टोर हो रहा है या फिर कंपाइलेशन टाइम पर स्टोर हो रहा है, ऑल दैट. और डेटा के साथ हम क्या कर सकते हैं, व्हाट ऑल कैन वी परफॉर्म, what all manipulations can we do with the data? Can we can we update the data, can we edit the data, can we delete the data, or what all can be done with the data? Can we perform any other calculation, arithmetic calculations, so on and so forth. So this is just the recap where we discussed about integer, float, character, pointer, etc. And now we are going into more complex data structures, right? More complex structures, and also known as non-primitive, which are not primitive, meaning a bit advanced data structures. And there is a linear data structure, stacks and queues, and then there is a non-linear. So linear, linear, right? And non-linear, linear, which can be represented in a line, that is a linear data structure. Non-linear is trees and graphs, which cannot be represented in a straight line. Now, there are different operations that can be performed on a linear data structure, which is insertion, deletion, searching, sorting, and merging. Inserting meaning that you insert elements into your data structure. Deletion, you can delete the element from the data structure. Searching, you can find a particular data element in the structure. Sorting, you can sort according to the ascending order, descending order. Merging, you can also merge the two data elements into one cell. Okay, now we also did structures before. So struct is like a class, collection of data where you have, let's say, a student will have different attributes, where student will have a name, gender, age, GPA, graduation year, etc. So these are all the attributes of a student. So a struct is a collection of the data, meaning a particular student and then the different attributes. So these are different types of data, right? Name will be string, age will be integer, GPA will again be can be a float, gender is gonna be character. So different kinds of different types of data, so data types are different. Okay, we use dot notation to access individual field values. I'm not going to go into this. This is basically, how you declare a struct. And here there's a program creating a struct student where there is a character name, 50 characters, integer age, integer year, float GPA. Then I'm creating a struct student s, and then also struct student pointer, right? I'm copying the name Freya to the s dot name. Age I'm assigning 18 to 2016 is year, GPA 4.0. So in my struct s, this is the object of your struct, right? S, the values are s Freya 18, 2016 and 4.0. Whereas the pointer, the rest of the s is will be assigned into the stack, whereas the pointer, the memory, the data allocation will happen during the execution time, and the data will be assigned during the runtime at heap, right? So when I use the pointer and malloc to assign the the content, the data, it is all going into the heap. So this is the difference between using a pointer or using a normal assignment, right? So normal assignment is on a stack, whereas a pointer assignment is on a heap. So what basically a stack is? So stack, you consider it as a stack of plates or a stack of toy or a stack of books, and it follows the last in first out order. Meaning when we keep the plates, right, we keep one plate on another, then another plate on another, then another, right? And what we do, the last plate that we kept, so you're on a kitchen table and you're keeping the plates one after another, one after another, one after another. The last plate that you kept will be the first one that you will pick up, isn't it? The last plate that you kept will be the first one that you pick up, right? That is last in first out order. You are, let's say you are piling books, so one book, then at the top another, then at the top another, then at the top. The last book that you kept is the first book that you're gonna pick up. That is stack. Okay, the last one to enter the stack will be the first one to be deleted or the first one to be removed. Okay, first one to be accessed. Okay, that is stacks. Two operations are here, push and pop. Push is to insert data into a stack, pop is to remove the data from the stack. Now push is to write to enter the data, insert the data, then that is the push. And you have to check that the stack is not full, right? If the stack is full, it's going to give you an error. Similarly for popping, meaning delete the data, you also have to check that the stack is not empty, because if stack is empty, then it's going to give you an error. Okay, now implementation of a stack, there are other functions for stack. Peak is full, is empty, so you have to check whether the stack is full, whether the stack is empty. Peak is basically get the top data element of the stack without removing it. Okay, so you simply peek it, you simply see what data element is there at the top of the stack and you retrieve it. That's it, without removing it. You don't remove it. Okay, then we have, now let's look here what is happening. Push operation to add elements. Basically this is an empty stack, the index position starts from 0. The first that goes into the stack is data 11 at position 0, and my pointer top goes to the second element, points to the second element or index position 1. Then I enter another element 22, the top is pointing to the second index position. Then I enter another element called 33, and the top is pointing to the another index position, right? So top is incremented. The top is nothing but just a pointer which is pointing to the data element, and it increments. And when its size is greater than the stack size, when the size is greater than stack size, then we know that it is full, right? When the size of top is greater than the stack size, then we know that it is full. We cannot now add further elements. So when the top is here, then top goes to position here, now then top goes to position here, and we know that the size has increased, or the size of the top has increased than the size of the stack, so we have to stop and adding the element. Pop is again the same thing. Pop is to delete the element, remove the element from the stack. So initially the top was at the index position 3, our elements are already there, so we will look first at position 3. There is no element, so we decrement the top. In here the top was getting incremented, plus 1, and here we are going to decrement the top. Top is nothing but an pointer which is pointing to the data element, so we'll remove 33 from the stack, and then the pointer is going to point to index position 2. So first index position 3, then index position 2. Then it will remove the 22, and it will point to index position 1. Then it's gonna remove the 11, and it's gonna point to index position 0. And then it will say that okay, now when we do top minus minus, it is less than the it is less than 0, so it's gonna stop. Okay, if it is less than 0, meaning it is equal to -1, it is stack is empty, so you have to stop it. So this is just a program where we are creating a stack to hold 5 elements, and then we are inserting the elements using push, and we are deleting the elements using pop, and we are using a top. Here it's not a pointer, just an integer, to increment and decrement, to check whether the stack is empty or full. And very straightforward, simple element, a simple program. And here we are creating, basically stack is an array of 5 elements, right? Stack is just a name, you can name anything, it is just an array of 5 elements. Now we'll come to queue. What is queue? Queue is another data structure which is uh, first in first out. So imagine you are standing in a bus line, right? So when you stand in a queue to enter into a bus, it's a first come first serve. The first one to stand in the queue is going to enter into the bus. Or you're standing in a banking, in a bank, you're standing in a line, so the first one to go to the bank manager is the first one in the line, right? So the first in first out, so the first one who is in the queue is the first one to get out of the queue. Okay, so or you are standing outside of a cinema hall to get the ticket, so you stand, and if you are the first in the line, you will get the ticket first, and the second will get the ticket last, the third will get the ticket, so on so forth. First in first out, so if you are the first one to enter, you will be the first one to leave. It is opposite to the stacks. Again, car parking area, the cars which are standing in a parking area, the first one that came would be the first one to leave. Okay, queue in a bank, supermarket, bus stand, etc. The first one to stand in the line would be the first one be attended. Now in the queue again we have insertion and deletion. Now insertion usually happens at the end of the queue. So when you go to the bank to stand in a line, you don't stand at the first, you stand at the last, right? Depending upon the line. So already 3 people are standing in front, so you stand at the fourth. So here also we add the element at the end of the queue. Okay, we don't add the element at the start of the queue, we add the element at the end of the queue, but we delete the element at the start of the queue. We delete the element at the start of the queue. Is empty, is full, is straightforward to check whether the queue is empty or full. Peek is to get the first front element without removing it, just the same as in stack. Now there are 2 pointers we use here, front and rear. Front is When you initialize the queue, we set the values of front and rear both at 0, right? when we enter when we enter an element in a queue, the front gets incremented. When we delete an element from a queue, rear gets incremented. Okay, so in our stack we had only one variable to take care of the insertion and the deletion, but in our queue we have two variables to take care of insertion and deletion. One is for insertion and another for deletion. Front is when you enter an element in a data structure in a queue, front gets incremented. And when you delete a data from a queue, rear gets incremented. Okay. And initially they are both 0. Now let's look here what is happening. So initially f and r, they are both pointing to 0. Okay, fine. This is the start of the queue. This is the end of the queue. Okay, fine. We insert element 11. So my f will point to 0 and my rear will become 1. Okay. Okay, yeah, sorry. I made a mistake. On adding the element, the rear becomes 1, and on adding, when we add the element, rear becomes 1, and when we delete the element, front becomes 1. Okay, when we add the element, rear becomes plus 1, and when we delete the element, front becomes plus 1. So rear has become 1. Now I'm adding 22, rear will become to next position, index position. 22 is added. Now I'm adding 33, rear goes to next index position, 33 is added. Now let's say I want to remove the element. I want to remove 11. So when I remove 11, my f will move forward. Okay. So I've removed the element. My f has gone to index position 1. Fine. Okay. DQ, NQ, DQ, NQ to add element in a queue and DQ to remove the element from the queue. Now I want to remove another element from the queue, which is 22. So as I remove 22, I move my front pointer again to point at 33, right? So now my f is at 33 and my r is at 3. Now I want to add element. So let's say I want to add another element. I add 44. What will happen? As I add 44 to index position 3, now I cannot directly jump to index position 0 and 1. Note, they will be empty. Okay, they will be empty. No matter, the queue is sequential. 44 has to go to index position 3, and my rear will move to fourth index position. Then I add 55. My rear moves to at the end of the queue. Okay. Now I want to delete my 33, my data point 33. What will happen to delete that? If I want to delete it, what's going to happen? My f will move forward, right? But anyway, we are stopping here, and then we say that the rear is index position 5 and my front is at index position 2. Now, can I insert another element into this queue? No, I cannot insert another element into this queue because my rear has crossed the maximum size. Rear is until 5, right? Less than 5. Rear has crossed the maximum 5, maximum size. So even though there are empty spaces, I cannot enter element. Okay. It is not possible to insert an element even though there are two vacant positions. To overcome this problem, the queue must be shifted to the beginning, right? The queue must be shifted so that there is a vacant. Okay, the front and rear has to be adjusted. So in order to do that, we have a circular queue, which we will discuss later on. But you understand the problem with the linear queue, right? So even though there are two vacant positions, we cannot enter 66 in the queue because rear has reached to the maximum size. In order to solve this problem, there is another queue known as circular queue, which we will understand later on. But for now, linear queue limitation is that it is time consuming, it is sequential, and in order to insert elements you have to shift the elements, so it's very time consuming. Second, even if the queue is full, vacant positions cannot be, even though the queue is not queue full, it will signal that it is full. Then we come to circular queue. Okay, now what is circular queue? So circular queue solves our problem of maximum size limit even though the queue is empty, right? Now here what is happening, both our f and r are pointing to 0 at the start. Okay, then we insert element, front is still pointing to 0. Rear becomes the formula, rear becomes rear plus 1 mod 6, so rear becomes 1. Then I entered 22, 33, 44, and 55. And what does rear becomes? Rear plus 1 mod 6. Rear plus 1 mod 6 equals to 5. Because now rear is what? How many elements I've added? 1, 2, 3, 4. So 4 plus 1, 5. So 5 mod 6. One element here I added. So 1 plus 1. Sorry, 0 plus 1. 1 mod 6 is 1. Then 0. Then here I've added, 1 was added. 1, okay. Then it was 1, 2, 3, 4. 4 plus 1, 5 mod 6 is 5. 5 mod 6 is 5, right? So rear becomes 5. Count becomes 5. Okay. Now what am I doing here? Delete an element. So I want to delete the element at the front of the queue. So what will happen to my f? My f was at 0, my f will get incremented, right? And I'm deleting this 11. 11 at index position 0 is deleted and my f moved to 22. Fine. Okay. Now f again, the formula is 1 plus 1 mod 2. So it was 0. Sorry, it was 0. 0 plus 1 mod 2. So 1 mod 0 plus 1 mod 6, which is 1. Okay. And then count is decremented. Okay, now what I want to do, I delete another element. So here my front was 1. Now when I delete it, so 1 plus 1, 2 mod 6. 1 plus 1, 2 mod 6 is 2, so it becomes 2. Okay, right? So what is happening here, since this is circular in nature, there is no front and back. Okay, so I can very easily insert by moving the r and by moving the f. Just the structure of the data structure has changed, and so the limitation of the linear queue is overcome. Okay, I don't know if you get it or not, but it is, once you get hang of it, once you understand it, it is not that difficult at all. So here we are again writing it in a program. We are inserting few elements into our queue. Now this is a linear queue, and then after inserting we are printing the elements in the queue, and then we are deleting the element. And note, when you delete the element, which one will get deleted? The first one that you added into the queue, or the last one that you added into the queue? The first one will get deleted because it is first in, first out. Okay, so difference again between stacks and queue. A lot of theory over here. Stacks follow last in first out. The element that is added in the end is will be the first one to leave. Queues, first in first out. The element added first will be deleted first. Stacks, only one pointer is used. Top incremented when element is added, decremented when element is deleted. Queue, there are two pointers, front and rear, and they are not simply incremented decremented, but the formula is mod, right? Plus 1 and mod. Functions are push and pop. Push to enter element into a stack, pop to delete an element from the stack. Is full, is empty are another functions to check whether stack is empty or stack is full. In our queue, the functions are enqueue and dequeue. To enter, insert or delete, sorry, insert and delete, yes, insert and delete. And then front and rear are two um, are two pointers to traverse through the queue. This is some work that I gave to my students, so I'm just going to leave it over here. They're very simple. So you are creating a struct, and then you are giving some attributes to that struct, and this is in C language. So simply creating struct and giving these attributes. Then you are creating another pointer, and pointer will allocate the memory dynamically in a heap, and then you are modifying the price with the use of pointers and displaying the result. The second one is using a stack. So you simply enter elements into a stack, and then you check whether the stack is full or empty by using is full or is empty. And then you use pop to delete the element, and then you see that whether the first element is going or the 600. When you use is delete, 100 will be removed or 600 will be removed. Since this is a stack and it is last in first out, so your 600 is going to be removed and not the 100. Doing the same question with the queue, and then you check again whether 100 will be removed or 600. This is first in first out, 100 will be removed, right? And then there is some global and local variable functions that I gave. So I'm going to stop this here. Anyway, this is the last slide, and yeah, that's it. Thank you.